Hello guys, and this is the mid dude, and today we're doing Edexcel C2 January 2005. So let's get right to it. So question number 1, find the first three terms in ascending powers of x of the binomial expansion of 3 plus 2x to the power of 5, giving each term in its simplest form. So the key thing here is that they want the first three terms, right? The first three terms, and obviously in ascending powers of x, so that would be 1x and then x squared. So that's what we would need, and we need in simplest form. So just to remind you what the binomial expansion of any form of these situations would be, it would be this over here, a plus b to the power n equals an, and this would be n1, and then we have also showed us what that would mean. Okay, so how do we apply it to the question at hand? The question is 3 plus 2x to the power of 5, right? So all we do is we just substitute these numbers into this equation over here. That's all we do. So this would become 3 plus 2x to the power of 5 equals, okay, so what's our n? You can see that our n is, in this case, is 5, right? So we just substitute, so that would be 3 to the power of 5, right? Plus, so n1, so that would be 5, 1. You can see here the n over here, I'll just highlight, so this is the n that we're looking at over here. So 5, 1, a to the power of n minus 1. So a is our 3, so this is times by 3 to the power of 5 minus 1. So I'll just write 5 minus 1 in brackets, and we times by our b, and you can see that our b over here is this is our b, right? So this would be times by 2x. Okay, so next, plus, same thing again, so this would be 5, 2, and then this would be 3 to the power of 5 take away 2. This would be, and then multiply it by, so b squared, so that'll be 2x whole squared. Okay, so how many terms do we need? We only need the first three terms, so this is as far as we should go, and now we can use a calculator to figure it out. But before that, we need to actually understand what's going on here. So let's simplify all of this. So this would be, so 3 to the power of 5, so if you put in the calculator, so that would be 3 to the power of 5 would be 243. So we have 2, 4, 3. Now you can see here that this 5, 1, right? We can rewrite this in this form, right? We can rewrite it. So in the calculator, there will be this button that you can do to get something called NCR in the calculator. So basically, all you have to do is punch in the numbers 5, this button, this NCR button, and then 1. What that does is it does this calculation that we can do manually for us. It does this calculation over here for us. Okay, so in that case, so I'll do it manually so you guys can see what's going on, but just know that you can also do it in the calculator to save time. Okay, so this would be, so 5 factorial, that's our n. Our r factorial is just 1, right? 1. n minus r is 4 factorial. So 4 factorial. Okay, times by 3 to the power of 4. So 3 to the power of 4 is 81. So 81, and then 81 times 2x. And let's rewrite this one as well. So this would be 5 factorial over 2 factorial times by 5 minus 2, which is 3 factorial, and times by, so what's 3 to the power of 5 take away 2, so that's 3 cubed, so that will be 3 cubed, so that will be 27, and then times by, let's simplify, so 2x whole squared will be 4x squared, because we're multiplying 2x by another 2x. So if we cross multiply, so this times this, you see the terms, so that would be 2, so 2 times 2 times x, so that would be 4x squared. Okay, so now let's simplify what's this. So this would be 243, so we're content with that. Plus, so what's 5 factorial? 5 factorial is what? 5 times 4 times 3 times 2 times 1, right? So that's our 5 factorial, right? So 5 factorial, if you can check, so 5 factorial is indeed, right, so 5 times 4 times 3 times 2 times 1, yep. Okay, 1 factorial is just 1, obviously, because 1 goes to 0, so now we're left with 4 factorial, so that will be 4 times 3 times 2 times 1, okay, times by our 81 times 2, so that will be our 162x, plus, let's do this again, so 5 times 4 times 2 times 1, sorry, 4 times 3 times 2 times 1, all over 2 factorial, so 2 times 1 times 3 times 2 times 1, and 27 times 4 is 108, so that'll be 108x squared. Okay, so all we have to do is simplify. You can see over here that all of this cancels out with this. It's 4 times 3 times 2 times 1 cancel out with that. Similarly here you can see, let's cancel what cancels out. So 4 3 2 3 2 1 cancels, and what else? You can see that the 4 can become a 2 now, because this 2 can also disappear. So you're left with 243 plus 5 times 162x plus, so this is 5 times 2, so 10 times 108x squared. So our final answer will be 243 plus 5 times 162, that will be 810x plus 1080x squared. So that is the final answer for this question. So let's see, so this is our answer. Okay, so this is our answer. All right, so you get 1 mark for each I think, yeah, so you get 1 mark for each individual, 1 mark for each individual term, and 1 mark for the working out. All right, okay, so moving on, question number 2. Okay, so the points A and B have coordinates 5 1 and 13 11 respectively. Find the coordinates of midpoint AB. Okay, so that's pretty simple. All we have to do is we have to add the coordinates, right, and divide by 2. Add the coordinates and divide by 2. Divide by 2. Right, because we want the midpoint, right? So this is pretty simple. So all we have to do is 5 plus 13 divided by 2, and minus 1 plus 11 divided by 2. So this can go to, so this is our, let's call our midpoint M. So our M is, so 5 plus 13 is 18. 18 divided by 2, so just write, so 18 over 2 and 10 over 2. So that is 9 and 5. That's our midpoint. Okay, so part B, given that AB is the diameter of the circle, find an equation for C. Okay, so we've been told that there is a circle. There's a circle, so let's see, this is the circle, right? And they told us that, let's say this is our A, this is our B, right? So A and B, and we know our midpoint is M, and we know its coordinate is 9 and 5, right? So what do we need to find? We need to find an equation for C. So C is a circle, right? The usual form of a circle is usually x minus a whole squared plus y minus b whole squared equals the radius squared, right? We have the two coordinates for the center already, so we know that this is going to be x minus 9 squared plus y minus 5 squared equals r squared. So we're left with the radius. Now we can do it two ways. We know the total distance. Sorry, we know the points of this straight line. We know this point B is 13, 11, and we know A is 5 and minus 1. If we take the distance from here to here, we can find the radius, or if we take the distance from M to B, we can also find the radius, right? Because we know that AM equals the radius and also MB equals the radius, because we know that AB is the diameter, right? AB is diameter. We know that, right? Okay, so we can use any one of them. I'm going to do M to B, right? So we now need to find the distance between these 2 points. And the way we do this is, so usually we have the distance formula. So we have D equals, it's usually square root of, so it's usually x2 minus x1 whole squared plus y2 minus y1 whole squared. That's usually the distance between 2 points. So we're just going to label our points. So this would be our x1, x1, y1. Nope, not y1. This would be our x2 and y2. So this would, the distance would be the distance, or I'd say let's rewrite the distance and write the radius, because that's the real distance, isn't it, between M and B. Okay, so this would be the square root of, so we have 13 take away 9 squared plus 11 take away 5 all squared. So R equals, so 13 minus 9 is 4, so 4 squared plus 6 squared, so that will be 16 plus 36, so that would be 52, right? So that would be 52. So now we know that R equals root 52, but an equation of a circle is R squared, so if we square both sides, root 52 squared, so that will give us 52. So our final answer will be, so if we can write equation for C will be x minus 9 squared plus y minus 5 squared equals 52. So that is our answer. So I can just do that. So this is our answer here. So this is our answer. So you get marks for obviously the answer itself and the working out as well. So that's fine. So I can just show you briefly what the marks are for. So this is usually the mark for A1, and the rest are method marks. So A1 featuring A1. So obviously if you get this right, you have to get this right and this right. So that's A1, and then there's another A1 there. And the method marks are calculating the radius, so over here and here, calculating the radius and the center. Okay, so now we move on to question number 3. Find, giving your answers to 3 significant figures where appropriate, the value for x for which 3 to the power x equals 5. Now these questions are very simple, and I urge everyone watching to try them out themselves. It's super easy. All you have to do is remember to log both sides, and then simplify, and then apply log rules to simplify. Okay, so let's try this. So that will be log 3 to the power x equals log 5. And now we know this is the power rule. This is the power. So this is the power rule where x can move down, right? So that would be x log 3. So this can go to here. X log 3 equals log 5. So x equals log 5 divided by log 3. And because they want it in 3 significant figures, so you go to your calculator, you write log, so you write, what's it, log 5 over log 3, and you get, so I usually write one more significant figure than required. So this is tip, always write the answer to one more than required, so that you can round properly, you can round accordingly. Okay, so the answer is 1.46497. So I've just like elongated it. So in this case, we can see that we only need 3 significant figures. So our fourth significant figure would be 1.464, right? So we only look at this one, the next one. This is the fourth one. Does it affect the 6? It doesn't, because it's not bigger than 5. So our answer is x equals 1.46. So that is our answer. Okay, so question number 5. Question number 3b. Log base 2 of the expression 2x plus 1 minus log base 2x equals 2. Now you can see here, this is the subtraction law. So this is subtraction of the same bases, same base. So you can divide. So for this, so you can see here they have the same base, so this rule can be applied. So when you subtract logarithms, you're actually dividing them. So this would be log base 2, 2x plus 1 divided by x, okay, equals 2. Now we know that this is the same thing. So now we have log of base something equals a number. So we have something like log a n equals x. So we know that a to the power of x will equal n. So we know we can conclude that this is 2x plus 1 over x equals 2 squared, right? So then we can say this is 2x plus 1 over x equals 4, right? We can move the x to the other side. You can multiply both sides by x. So that will be 2x plus 1 equals 4x. And then move the 2x to the other side. That will be 1 equals 2x. So x equals a half, right? Or 0.5. I personally prefer fractions. They're easier to deal with. So x equals a half. So this is your answer. So you get obviously a mark for this, and 3 marks for the working out. So you get a mark for each step of working out. So this is 1 mark. So let me do another color. So this is M1. This is our method mark 1. This is our method mark 2. This is our method mark 3. And this is our A1, our answer, right? Answer accuracy. I think that's what it's called. Okay, so question number 5 now. Question number 4, sorry. Show that the equation 5 cos squared x equals 3 bracket 1 plus sine x can be written as this expression, this expression over here. This expression over here. Now, let's see how we can get from here to there. So, first thing we should do is expand this bracket what we have here to see how close can we get to this that we're doing here. So this is 5 cos squared x equals 3 plus 3 sine x. Okay, you can see that the sine x is fine, it's the same. There's a number, right? The only difference here is we have a sine squared and we have a cos squared. Now, remembering back to the identity, it's sine squared x plus cos squared x equals 1, right? You can interchange the variables and substitute, right? So in this case, they want us to show what sine squared x is, right? They want us to write the equation in terms of sine squared x and sine x. So we have to make sine squared x the subject here. So that will be sine squared x equals 1 take away cos squared x. And what we do is we substitute that in, yes, sine squared x, but in this case you can see that we have cos squared x, so we have to make cos squared x the subject instead. So that will be cos squared x equals 1 take away sine squared x, and we substitute that into over here. So how will we write that down? So that will be our, so if I write part A over here, this is also part of part A, by the way. So 5 times 1 minus sine squared x equals 3 plus 3 sine x. Now all we do is we just expand, so that'll be 5 minus 5 sine squared x equals 3 plus 3 sine x, and we move the sine squared x to the other side and the 5 to the other side, so that will be 5 sine squared x, so that will be 0, plus 3 sine x plus 3 take away 5. So our final answer will be, obviously we need to show, so sine squared x plus 3 sine x minus 2 equals 0. So in a show that question, the answer are the steps. So the steps are the answers to the question. There is no set answer to the question, but the proof itself is the answer. So I can't highlight what the answer is, it's the proof. All of these working out are part of the answer. Okay, part B, hence solve for 0 x goes to x is less than 360 of this equation. Now they've made it easy for us. Instead of using this, right, we can straight away use this, right? We can say this is the same thing as saying 5 sine squared x plus 3 sine x minus 2 equals 0. Now this is very similar to our ax squared plus bx plus c equals 0, right? This is a quadratic equation, right? So what we can do is we can make sine squared x equal a variable, and we can just do that. We can just solve it like a quadratic equation. Okay, so we can say that sine x, right? We can write sine x, let's say, equals y, right? So in this case, when you substitute here, so this would be y squared, this would be y, 3y, this would be 5y squared plus 3y minus 2 equals 0. So that case would be 5y squared plus 3y minus 2 equals 0. Now there are multiple methods to go about doing this. You can use the quadratic formula after this. You can do many things. So after this step, we need to find what y is. You can do multiple steps here. You could factorize if it's possible. Quadratic formula. Completing the square, if you want to do that, completing the square, or just using the calculator, obviously showing your work out. So when you use your calculator to find the answer, use the calculator, show one of the above working out, just to be on the safe side. Okay, so I think we can factorize this. So we can factorize this. So this would be 5y. Take y on the other side. Okay, so we want plus 3. So this would be minus plus 1. Take away 2 equals 0. Does it check out? Let's multiply it. So if we multiply it, so check out, so it's 5y squared plus 5y, take away 2y, minus 2. It does check out, you're right. So 5y squared plus 3y minus 2 equals 0. It does check out, so it is correct. So this is just to check, so this is not necessary. This part over here is just to check, you're working out your factorization. You don't have to do it. Okay, so now we can say that this is so now we can say that 5y take away 2 bracket y plus 1 equals 0. So we have 5y minus 2 equals 0, and similarly y plus 1 equals 0. So we're left with 5y equals 2, y equals 2 over 5, and y equals negative 1. So we remember that the sine x equals y is the same thing as the y over here, right? So we can just substitute back into this. So this would be sine x equals 2 over 5, and this will be sine x equals negative 1. Okay, so we take the inverse of both sides. We take the inverse, that will be, so x equals sine inverse of 2 over 5, and we get 23.6 degrees. Let's see, they want it to 1 decimal place where appropriate. This is 1 decimal place, so it's fine. 23.6. And let's see the other part. So this is x equals sine inverse of negative 1. So that is 270. So yep, sine inverse negative 1. Make sure your calculator is in degrees. There's always a common mistake there. So sine 270, so it's sine 270 or it's sine 90 or negative 90, but we don't want that. Okay, so let's go back. They want all the answers that are outside the range, right? So they want the answer from 0 to 360. Now if you remember, we know that there is this CAS diagram we have, C, A, S, and T, right? We know that if this is 23.6 degrees, if we do 180 take away that answer, right, this is also going to be positive, right? 23.6 degrees here. So what we have to do here is to find, so this is the answer, it's this angle here, isn't it, for our other solution. So it's 180 take away that angle, 23.6, so that'll be 180 take away 23.6 degrees. So our final answers will be x equals, so obviously 23.6 degrees. Then we have so 180 take away 23.6 is, so 180 take away 23.6 is 156.4. So 156.4 degrees, and also our other, so 270 degrees. Okay, so our final answer, this is our final answer. We ignore negative 90 because it's outside the range, so ignore negative 90 because outside range. Okay, all right, so now what, so we can see that, so that's the answer to this. Now question number 5, f of x equals x cubed minus 2x squared plus ax plus b, where a and b are constants. So when f of x is divided by x minus 2, the remainder is 1. So that means that f of 2 is 1. Now it's very important, whenever they say that the function is divided by a linear expression, x minus 2 or x plus 2 or x plus 3, we know that the function of that, so if we have let's say f of x is divided by let's say x minus 3, right? In this case, and the remainder is, they tell you, is 45. So f of 3 has to equal 45. That's how it works. Okay, same thing here. So f of x is divided by x plus 1. So we do the opposite on the inside. So that will be f of minus 1 equals 28. Now find the value of a and the value of b. So you can see in the equation there are gaps, right? A and b, they're not there, are they? So what we can do is we can, let's see, so let's substitute them, right? So if we do f of 2, so part A, so let's substitute it and let's see where we can go from there. So f of 2 will be 2 cubed minus 2 times 2 squared plus 2x plus, sorry, not 2x, so 2a plus b, and that equals 1, right? F of negative 1 will be negative 1 cubed minus 2 times negative 1 squared minus a plus b equals 28. So now let's simplify this. So this will be 8, so this is 8, so 8 minus 2 times 2 is also 8. So this will be just 2a plus b equals 1. So that's our first equation that we can use to solve simultaneously. You can see there are two variables, we have two equations, so we can solve simultaneously. Okay, so this would be, we will have, so in this case, so this would be minus 1 squared is 1, so minus 2 minus a plus b, so equals 28. When we simplify this, so this will be minus a plus b equals, so minus 1 minus 3 goes to the other side, equals 31. So now the simplest way will be just to take away, so we get rid of the b's, so that will be 3a equals 1 minus 31, which is negative 30. So this would be 3a equals negative 30, a equals minus 30 over 3, so equals negative 10. So you can just box that up, minus 10. Okay, and then we can just say that this is our a, so a equals minus 10. And now we can easily find what b is, so minus a plus b equals 31, so that would be minus 10 plus b equals 31, so that will be 10 plus b equals 31, so b equals 31, take away 10, 21. So we can write b equals 21, and we can also box that up and highlight it. So there we have it. So that's our a and b. So you get, obviously you get 2 marks for a and b, and the rest is for the working out, so finding the simultaneous equations. That's our part A. Now part B says, so how do we show that x minus 3 is a factor of f of x? Now to show something is a factor of f of x, all you have to do, so let's say this is x minus p, right, some xp, and you want to show it's a factor of f of x, you have to do f of p must equal 0, or else it is not a factor. It is not a factor. So all we have to do is do f of 3 and show that it equals 0. So in that case, that will be f of 3. So our equation is, so 3 cubed minus 2 times 3 times squared. We know what a is now, right? We know it's a is minus 10, so minus 10 times 3. We know what b is, it's plus 21. So now all we have to do is simplify. So that will be 9 minus 2 times 3 squared, so that'll be minus 18 minus 30 plus 21, if I'm correct. Oh, not 9, sorry, that was my bad. So that is 27. 3 cubed is 27, not 9. So 27 minus 18 minus, so what I usually do is I want all the additions to be on one side and all the subtraction to be on one side, so I simplify it further and I write, so 27 plus 21 is 47, if I'm correct. 47, 27, oh, so 48, sorry, 48, and this would be minus 48 and equals 0. Hence x minus 3 must be a factor. Okay, so that's that. Again, I show that question. So the solution is, this is the solution, like you're showing that it equals 0 is the solution. There is no set solution, as in I can't highlight it. If I want to highlight, I would highlight the whole thing, which I do not want to do. But for the sake of clarity, so you have to say that you have to show that this equals 0 and f of 3 basically, and at the end you must conclude that x minus 3 must be a factor. Okay, so question number 6. The second and fourth terms of a geometric sequence are 7.2 and 5.8332 respectively. So the common ratio of the series is positive. For this series, find the common ratio. Now, what is a geometric series? Now, geometric series are usually AR to the power, so AR to the power n minus 1. That's usually a geometric sequence, right? The nth term of a geometric sequence. So the second term will be, the second term will be, so 2 take away 1, which is 1, so that will be just AR equals 7.2. The fourth term will be AR cubed, so AR cubed equals 5.832. So we know that, right? We know this. So now what? We need to find the common ratio. Now the common ratio is R, right? So this is our R, and the first term is A. Just so we're clear, right? So we have AR and we have AR cubed, and we know what they're equal to. So we want to get rid of the A. So what we can do is we can do AR cubed divided by AR to get rid of the A, right? So we can do that. Let's try that. So the A would disappear and R would become R cubed. So the R squared, sorry. So that would be our 5.832 divided by 7.2, right? So R squared will be, let's simplify this, because or not, we can, let's simplify this. So 5.832 divided by 7.2, which is 0.81. So if we square root it, will be 0.9. So R equals 0.9. So we know that's 0.9. Okay, so they tell us the common ratio of the series is positive, so we know it's going to be the positive, because we know the square root of something, R can be plus or minus 0.9, right? Because it's square root, isn't it? It's plus or minus. So, but they tell you that it's positive in the question, so R must be 0.9, plus 0.9. We don't write the plus, but we assume the plus, right? So it's 0.9. And it's not, so R does not equal minus 0.9. So that's also very important. It does not equal, because in the question it says it's positive. So how do you find the first term? We can easily find it now because we know what R is. So we can write AR equals 7.2. So A times 0.9 equals 7.2. So A equals 7.2 divided by 0.9. So that equals 8. So A equals 8. So that is our answer for this. Now, they tell you to find the sum of the first 50 terms, giving you answer to 3 decimal places. Now, if you remember, the sum to n numbers, right? It's usually A bracket 1 minus Rn over 1 minus R, right? So in this case, that will be, so let me elongate, that will be s to the power, so as 50 terms will be 8, a's are 8, 1 minus, what's R? 0.9 to the power of 50, all the way 1 minus 0.9. That's all you have to do. And we just put this in our calculator. So that will be, so let's see what that is. So that is 8 times 8 times 1, 0.9 to the power of 50, 1 minus 0.9, and they want to 3 decimal places, so I'm going to write so 79.5876. So I'm writing 4 decimal places so I can round it. That'll be 79.588 to 3 dp, 3 decimal places. So that is 79.588. Okay, so that's that. Now they want the difference between the sum to infinity and the sum of the first 50 terms, giving you answers to 3 decimal places. I didn't class this as C, D. So they want the difference between S infinity and S50. What is S infinity? S infinity, the sum to infinity is usually A over 1 minus R, right? So that is the general formula, right? So we can substitute, so that will be 8 over 1 minus 0.9, and that is 80, right? So 8 over 0.1 is 8 divided by 8 times 10, so 80. And we already know what S50 is, so that was, so S infinity, that was a bad infinity sign, S infinity take away S50, we already know what S50 is because of the previous question. That'll be 80 minus 79.588. So that will be, you put this in the calculator, so 80 take away answer, so that will be 0.412. So our answer is 0.412. Okay, let's move on. So question number 7. So the figure 1 shows a triangle with the ABC. AB is 8 centimeter, AC is 11, and they tell you the angle between the two. So what are they asking? They're asking for, the first question says, the length of arc BD. Now arc length is usually r theta when we have radians, and so it's very self-explanatory. So all we have to do is to remember this formula. This is for arc length, so I'll just write it down. So this is arc length, so you remember it. So this is just to substitute. So what's the radius? The radius they tell you is 8 centimeters because AB, right? So they tell you that. So radius is 8 centimeters. You can see over here, radius is 8 centimeters. So you know what's going on. So that will be 8 times 0.7. So that will be 5.6 centimeters arc BD, right? So let's just do that. So that will be 5.6. Let me 5.6 centimeters. Okay, the perimeter of R, giving your answer to 3 significant figures. So we need to find the length of DC and BC, right? To find this out, we can find out the length of DC very easily because we know A to D is 8 centimeters. So we know DC. So we know that 8 plus DC will equal 11 centimeters. So DC is equal to 11 minus 8, so it must be 3 centimeters, right? So this will be 3 centimeters. So we can say this 3 centimeters. So now we're left with, we have a triangle, we have 2 sides and an angle, and we want to find out the other angle, the other side. This is the cos rule. This is the cosine rule. So how do we use it? We know that this is, so we can say it's usually a squared equals b squared plus c squared minus 2bc cos A. So in this sense, that would be, we have to clarify, so this will be bc squared, and then it will be No, get rid of this. Okay, so that will be our AB squared plus AC squared minus 2AB AC cosine of A, in this case, which is 0.7. This is our A. So I can just write it over here. BC squared will be, so that will be 8 squared plus the whole, so this length over here is 11, so plus 11 squared minus 2 times 8 times 11 cosine of 0.7. Remember, this is in radians, so calculator must also be in radians, so I'll just highlight another color, so radians. So it's very important to change your calculator to radians. And you don't even have to know what the answer to this is. All you have to do is BC in the calculator, just square root that same answer. So all you have to do is basically this. All you have to do is this. Yeah, all you have to do is this, and then you'll be left with BC equals, the square root of all that will equal 7.098. So we know that this is 7.098. So we can write our perimeter, so of R, so the perimeter, so this is, let me add B here, perimeter will be of R will be 5.6, the arc, right? 5.6 plus 3, which is DC, right? Plus 7.098. So that will be, when you add them, so that will be, so let's see, that'll be 5.6 plus 3 plus 7.098. So that'll be 15.698. But they want the answer in 3 sig fig, so that'll be 15.7 centimeters to 3 SF. So that's our final answer for part B. So that's the answer. Part C says find the area of R. So how can we find the area of R? The only way we can find the area of R, right? Of R is if we find the area of the triangle, right? Triangle. Take away the area of the sector. So we have to find the area of the triangle and the area of the sector, right? That's the only way we can get R. So let me draw it first. So C will be area of triangle, take away area of sector. So let me make it more clear. Sector equals area of R. That's pretty simple. So how do you find the area of a triangle when we have two given sides and an angle? It's half AB sine C. So half AB sine C. So this would be 8. So I'll just write it down. So triangle area will be half AB sine C. And the area of a sector, given the radius, will also be half R squared. Half R squared theta. So in this case, that will be half times 8 times 11 times sine of 0.7. Take away half times 8 squared times 0.7. That will be, so now all we have to do is put this in the calculator, so you'll get So you get, so this one will be 0.5 times 8 times 11 times sine 0.7. So that will be 0.5375. Take away the area of, so you obviously put this in the calculator, all of this in the calculator, but write down the working out, right? So 0.5 times 8 squared times 0.7. So take away 22.4, half r squared, half ab sine ab sine c. Nope. My thing is in, see, I made a mistake. It should be in radians. Let me try again. Yep, that's my fault. This over here is wrong. This will be 28.34. Take away 22.4. So our final answer will be 245 will be 5.9455 centimeters squared, and area of R to 3 sig fig will be 5.95 centimeter squared. So that is the answer for C. Let's move on to question number 8. So it says the line with the equation 3x plus 20 cuts the curve with this. Use algebra to find the coordinates of A and B. So we need to find the intersections, right? Find the intersections. So that will be, how to do that? That will be 3x plus 20 equals x squared plus 6x plus 10. So move to the other side, becomes 0. This becomes x squared plus 3x minus 10. And you can factorize this to x plus 5, x minus 2. And you will get, so x equals 2 or x equals negative 5. But because we want the coordinate that includes, so that means y included, right? We have to substitute this back into the original equation. The easiest one is y equals 3x plus 20, right? So we substitute, so y equals, so for x equals 2, this will be 3 times 2 plus 20. It'll be 6 plus 20, so 26. So we know that our b, because this is 226, this is clearly the higher one, so we can say that b is 226. And the other one, x equals negative 5, so that will be y equals 3 times negative 5 plus 20. That will be negative 15 plus 20. That will be 5. So we know that a will be minus 5 and 5. So we know that. That's pretty good. Part B, the shaded S region is bounded by the line and the curve as shown in the figure 2. Use calculus to find the exact area of S. Okay, so there's a trick to this. You can do something called the integration of the line take away the curve. Now why do we do that? Let me explain. So if we take the integration of just the line, right, from the points A and B, so that will be all the area from here all the way down to here, right? It'll be everything here. It'll be everything here. Yes? So let me make it a bit more clear. Okay, so it'll be the area from all the way from A, so it'll be all this area, right? Let me make it very clear. It'll be all this area. It'll be all this area. Okay? And if we subtract separately the integration of the curve, right? That will be, and obviously from the same points, obviously we're talking about the same points. That will be from here all the way to here. And if we do that, we will get what? We will get what we wanted initially. We will get the area of s, right? So to make the process faster, we can just do it, we can just combine the process, and we can just do the integration of the line, take away the curve. So what's the line is 3x plus 20. So the limits are the x limits, so that will be minus 5 and 2. So the line is 3x plus 20 take away x squared plus 6x plus 10 dx. So that will be, so let's simplify this, that will be minus 5 to, so 3x is minus x squared, 20 take away 10, so that will be 10. So 3x minus 6x will be minus 3x minus x squared dx. So this goes to, so this is 10x, obviously this is 3x squared over 2, because raise the power, divide by 2, 3x squared over 2, that will be minus x cubed over 3 to the limits 2 and minus 5. All we have to do now is substitute the limits. So that will be 10 take away, so 10 times 2 minus 3 2 squared over 2, no, that looks like a cubed, sorry, 3 2 squared over 2 minus 2 cubed over 3 take away, so 10 times negative 5 minus 3 times negative 5 squared over 2 minus negative 5 cubed over 3. And then this is a very important step, right? You have to show this in the, you have to show this part, you have to show that it's this small part you have to show, sorry, this part you have to show. This is 34 over 3 take away the bracket, so that will be fine, so that will be 275 negative 275 all over 6, and that will be, so if we do that, so that will be 343 all over, so if I get this correct, this weight, so that will be 11 34 over 3 and 45 5 6 275 over 6, yeah, 343 all over, so if I get this correct, so that will be 343 over 6, which you can simplify to 57 and 1/6, and that is your answer, the exact area of S, so units squared. So that is the answer for part B. This is also correct, and also this is also correct. Both are correct. I prefer this one. This is more concrete and more, it has a mixed number. It's you know, like, you know the unit, it's not a fraction. It's better that way. So question number 9. So we've been given this figure. Figure 3 shows the plan of a state. So this is the figure, and they tell you that the diameter, they tell you lots of things here. Let's see what the key points are. So you can see here, this is the length of the rectangular part is 2x meters, and well, the width is y. They've done this for us, and you can see here 2x meters and y meters. But they also tell you that the diameter of the semicircle is also 2x, obviously, over here, so this also must be 2x meters. So the radius from here to here must be x, right? So that we know that as well. And the perimeter, they tell you, is 80. So that's the main thing, right? So perimeter is 80. Okay, so they tell you that, show that the area is that, right? So how do we do that? What is the area? The area we know is the area we know. So area will be the area of the semicircle over here. So area A1 and area of this, right? So we know that. So the area of the, so A2 will be just 2x times y, so just 2xy, and A1 will be half times an area of a circle, which is pi r squared, in this case pi x squared, right? So we know that, right? We know this, so it's pi x, so we know that the area should be 2xy plus pi x squared over 2. Now you can see here y is not there, right? So we need to get rid of it. We need to get rid of this. How do we do this? Well, this is where the perimeter comes in handy. There's a reason they've given us the perimeter and not asked us anything about it. We need to use the perimeter. So how do we use the perimeter to help us here? So let's look at the perimeter. So that will be y over here. So we know the circumference of a semicircle is 2 pi r. So in this case, it will be 2 pi x, right? So I'll just assert circumference is 2 pi x. In this case, we half it, so it's just pi x, right? So we know this is pi x. We know this is y. So we know that AT equals, so it'll be y plus 2x plus y plus pi x, right? So let's simplify this. So the AT equals 2y plus 2x plus pi x. So we want what y is, so let's make y the subject. So we're going upwards here. So that would be, so AT minus 2x minus pi x all divided by 2 equals y, right? So that's what we know so far, right? That's what we know. All I've done is we rearrange. So from here to here, all I've done is rearranged the formulae. Rearrange the formula. Okay, so how do you do that? So I mean, what do you do next? We just substitute it, right? So our a will be 2x times y. We know what y is now, right? It's that, right? So 2 times that will, so area is, it's 2xy, so it's 2x times AT minus 2x minus pi x all over 2 plus pi x squared over 2. So in this case, so the 2 will cancel out, so you're left with ATX minus 2x squared minus pi x squared plus pi x squared over 2. So when you simplify this, so this will be a equals ATX minus 2x squared, and this will be plus pi x squared over 2. You can see here they've taken x squared as a common factor, so you can say that a equals, you can write ATX minus, so you can take out the bracket, 2 plus pi over 2 x squared. Alright, so done that. What else? Minus pi x, sorry, this is, I made a mistake here, this is actually minus, because we have minus pi x plus pi x, so that will be minus. Okay. Use calculus to prove the value of x which it has a stationary value. So that will be dA over dx, right? So dA over dx. We differentiate it, what will we get? We will get. So first we have to simplify a, what a is. So a is actually just, you know, AT minus 2x squared minus pi over 2x squared. So that will be ATX, sorry. So when you differentiate it, you will get AT, right? AT minus 4x minus pi x. And now we need to equate it to 0. So that will be AT equals 4x plus pi x. So x will be 4 plus pi, like, you know, simplify it. So AT. So x equals AT over 4 plus pi. So that's that. So we know that that is our answer. So we know x equals 80 over 4 plus pi. I'm going to leave it there because you don't need to simplify it further. They have not asked you for it. They just asked for the value. C, part C says, prove that the value you have for x in part B gives the maximum. So how can we do that? We have to differentiate it twice, right? D squared A over dx squared, right, equals, so minus 4 minus pi. Now this is less than 0, right? So that means this is a maximum value because d squared A over dx squared is less than 0. Okay, part D, find the maximum area. All we have to do is just A equals, so AT times AT over 4 plus pi minus 2 minus 2 plus pi over 2 at over 4 plus pi whole squared. So area will equal, and simplify this will be 448 meters to the nearest meter. 448 meters. So this is our final answer, and that is the end of the video. I hope you enjoyed it. Please like, share, subscribe, and tell other people about it so they can benefit. And I'd say that practice makes perfect, in especially in maths anyways. So I'll see you next time.